A porter lifts a heavy suitcase of mass 80 kilogram and the destination lowers it down by a distance of 80 centimeter with a constant velocity. Calculate the work done by the porter in lowering the suitcase. So first, as usual, we will try to visualize the given data here. So we have porter lifting the suitcase and he is lowering it, and the lowering distance is 80 centimeter. Now calculate the work done is being asked in the question. So we know that by work energy theorem, with respect to the suitcase, work done by all the forces should be equal to change in kinetic energy of the suitcase. So it is for the suitcase and not for the porter. So all the discussion here would be with respect to the suitcase. Now, what are the forces acting on the suitcase? Let us first go through that. So if we consider the suitcase, the first force that we'll have to account for would be the force of gravity. Second would be the force acting on the suitcase by virtue of being in contact with the porter, which otherwise is the normal reaction. So I'll call it here force on the suitcase due to the man, FSM. Okay. And if we consider this motion, since the suitcase is lowered down, I would say that the direction of displacement is downwards. So direction of displacement here is downwards. So we have only two forces acting on the suitcase. One is gravity and the other is force on the suitcase due to the man. Now let's see. Work done by all forces will be the sum of work done by gravity plus work done by the force on suitcase due to the man will be equal to half m into Vf square minus Vi square. But it is given that it is lowered with constant velocity. Now since it is lowered with constant velocity, Vf would be equal to Vi, therefore this complete term would become 0. Now we'll have to evaluate work done by gravity and work done by the man. So what is work done by gravity? Now if I have to write it more in a more explained way, I would write work done by gravity will be equal to the vector gravity dot displacement vector, which is, what is F dot S? Magnitude of F, which is mg times magnitude of vector S, which is S times cos theta, right? Now how do we find out theta? Theta is the angle between the force of gravity and that of the displacement vector. So if you consider these two vectors here, maybe I'll just draw it separately. So if you consider the weight and if you consider displacement vector, these to be the weight and displacement vectors, then we have the angle between them to be 0 degree, right? So this expression becomes mg times s times cos theta would become cos 0, which is 1. So if this expression here cos 0 becomes 1. So we have mgs plus work done by man is equal to 0, which means work done by man is equal to minus mgs, or work done by man is equal to what is mass? Mass is given to be 80, g is 10. Well, I think there is a small difference. It is given, it is said to us that we should take g is equal to 9.7, but for the sake of easy calculation I have done it here using 10. So we have 80 into 10 into 80, which is 0.000 by 100, so we have 640, so approximately 640 joules, which means, let me just bring the answer here. Okay, so the correct answer would be 620. Okay, there are two options, right? So yes, minus is specified, so it is minus 622 7.2 joules, which is the most closest to 640. Now, if you ask that, what if the question has an option, say 635 joules, then I think we should not be taking any risk. We should follow the calculation of the same calculation using G is equal to 9.8.